Anyway, so we started this panel, and it's an open mic panel. We talk about whatever you guys want to talk about. It was curious yesterday that Professor Hu's keynote had these two slides, which he's going to put up there to refresh your memory. That you looked at those two slides and said, wow, there's lots of things we can talk about at the panel. And so some of us deferred until the panel discussing them. André Seznec, who's one of the best microarchitects in the business. He's at INRIA, and you know, he's done incredibly good work in branch prediction, in crazy organizations for caches, et cetera, et cetera. And he says, wow, if Wen-mei has two slides up there. What I don't understand is why he thinks he can get away for only 20 euros.
Because he's really good.
And so he says, well, if Wen-mei's going to have two slides, I want two slides. So, what I think we will do, and by the way, as I said, Trevor's not here. So he's here. He's the fourth person on the panel today. I wish he were here, but he had something that just he couldn't get away, and the hope is he'll be back next year. The panel is open mic, so we'll talk about whatever you guys want to talk about. I propose we start with letting André talk about his two slides. I've told him he can have 2 minutes to do that, and then Wen-mei, you can flash those two slides again just to refresh everybody's memory.
1 minute.
1 minute, and then we discuss, and hopefully there'll be lots of good discussion carried on after the panel to SAMOS and the rest of the conference. My job is just to referee, but I might have something to say also. I have been known to do that. Okay, so why don't you start it?
Just a few reflections about microarchitecture research. I've been in this job for a long, long time. White hair.
That's not as long as some of us, however.
Yeah, I know. And when you look at what happened before 2000, we were all trying to use all the transistors to achieve the highest performance as you can. Okay, and it ended with this strange research where you could not get a paper accepted except if you were using simple scala, and I regret that Todd is not around because...
Yeah, is Patt in the audience?
No, he's gone.
And, I invited Todd actually to be on the panel, but
simple scala and simple, which was quite strange in some sense. So we have to think about our community going just ignoring research when you don't use the tools that are fashion. Okay. After 2000, so we completely changed. Okay. Oh my God, you cannot burn all this energy, all this power. Okay. And it continues up to now, and it's strangely with no idea, except if you are using watch, MacPad, hotspot, all these fashion tools. So that's a thinking about the microarchitecture research we're doing. And I have a second slide. It's time to new ideas, and we should not take into account all these constraints. Okay, just the silicon area is now a second-order issue. We can use the area of tens of complex cores. Just imagine you are not doing research for the processor that is coming tomorrow. That's too late. Okay, you are doing research for the processor that is coming in 10 years from now. 5, maybe you can influence a little bit. 10 is just the right time. And at that time, you will have space for hundreds of cores. So, power of energy of a single core is not an issue also. Okay? You could use say, oh, I concentrate all the power for 10 or 20 or 50 cores in a single core. So just do research as if you were able to use all the power that you want. And somebody will deal with this constraint, will solve this constraint. Okay? That's my 2 minutes. No reaction.
Yeah, so I have a big reaction, but I thought I'd wait till Wen-mei, you want my big reaction? Or you want Charlie
I
to
actually
Wen-mei?
think people will have big reactions because after chairing so many program committees, I can predict that these papers will be rejected at the end. They even shouldn't be.
Which papers?
The kind of papers that André is talking about.
Yeah, so my problem with simple scalar is, I read some papers that showed performance benefit with simple scalar, and I looked at it, this is counterintuitive, I just don't get it. And then we found out later on that it was a bug in simple scalar. And if you correct the bug in simple scalar, what started out as a performance win ended up being a performance lose. In fact, what simple scalar did badly, in my view, this was not the intent of Todd Austin or Steve Bennett or Doug Berger. But what it created was the ability to get papers to submit while remaining clueless about anything that was going on.
Yeah, that's true.
Not the microarchitecture, and then his other bullet about using Watch or Patt, which reminds me, if you want to know what's going on with the computer, why don't you put a stethoscope in your ears and put the thing on the cabinet of the computer, and maybe they'll tell what's going on in the computer. And so what you have is a person who's clueless about architecture, but has simple scalar. And so it twiddles the knobs, and then simple scalar runs, it produces data. Now, I don't know how many of you are Unix savvy, probably most of you, I hope, so you understand the concept of piping. So what I would do is have the output of simple scalar piped to the barcode generator, see? And then the output of the barcode generator piped to the paper writer, which we're going to be in the artificial intelligence age of writing the paper. And then the output of the paper writer piped to the program committee. And we could automate the program committee so you can twiddle the knobs and get the result whether your paper was accepted or not, and remain totally clueless of anything going on.
Yeah. In this one more stage, it should be piped into the promotions committee.
So, we had the good fortune to have Bill Daly here last year, who created a type of architecture that's
Actually, it was Ed Lee, but Ed Lee.
I'm sorry, Ed Lee. Sorry. Same
all
Ed
stand
Lee.
from they say 50,000 feet, from 10 feet up, all Stanford people look alike, right?
Yes. But the point is,
they teach 10% of the time, they form companies,
and then they
90%
start,
of the
yes.
time, right?
And they have an architecture that does not adhere to the pre-2000 run it through simple scalar or you don't get into micro, or now run it through one of the other in vogue programs where it doesn't get published. And I think this is exactly the point. And from embedded systems, you see a lot of this stuff that really doesn't depend on those kind of workloads. And the question is, what's the venue for that type of paper? I guess it's not micro, but
Yeah, it's micro. The problem is one needs to fix micro.
I guess we have the opportunity here.
Well, so I'll spend my 1 minute, and then we should really open up to the audience. So yesterday I already talked about these points. I'm not going to belabor, but just quickly remind you, as an academic discipline, I'd like to see more of the senior people here in top reference, cited computer scientists. As a discipline, it's really not good for us not to have people who are in that level. And even though we love our micro papers, ISCA papers, and so on, and we say it's very competitive, in reality, we have very modest citation counts for ISCA papers for various reasons. One of the reasons might be that people don't read these papers. Who knows? But I'd like to have your view about that. And few top institutions consider computer architecture as a high priority hiring area. You know what? I have been fighting this in my own institution, and I'd like to hear what you say. and if we can fix it quickly. A few venture capitalists consider computer architecture as a major source of big, startups. And you know what? Do we have a lot of young people here who eventually would like to have a big startup or some kind of your career? You know what? We want to be able to to support these people in our discipline. Potential actions: take charge of the major application programming interfaces. And you know what? I don't think we are, as a community, we are really into the reality, the industry practice programming interfaces. We're not influencing or helping to move these interfaces the way we should. Teach programmers what they need to know about computer architecture. And I'd like to see many of you teaching the application developers what they really need to know to be able to build scalable, energy-efficient applications. Encourage computer architecture students to understand more about applications and numerical methods, and rethink the scope of computer architecture conferences. Are we really going to foster an environment where we really will generate all those ideas, right, in the next decade? Let's talk about it, right?
Okay, so who wants to start it off? If one of you don't, I will, so there you go.
Okay.
Just go.
So I have a case study for, say, points to highlight, and I would like some input from, say, participants in the panel. So I've defended my thesis on the difficulty of a computer architect to revisit the hardware-software interface. So in the text of my thesis, I have one part which describes the work of my colleagues on the architectural level. Then I have another part which describes my contribution as a system software implementer to make compiler and operating system technology. And then I reflect on the difficulty we have to publish results, because although we have made a lot of work to implement and produce tools and technology, we still cannot run things like spec or other benchmark suits that everyone else is using, because we have limited effort. Our effort is to do architecture and minimal amount of tooling, but we cannot spend the time we have implementing benchmarks for our new architecture, for our new actually ISA. And now my question would be, my thesis concluded saying, if you want to do disruptive research, you have to preserve compatibility with the machine models that programmers have in their minds, and you should have minimal compatibility with existing operating systems so you can rerun existing benchmarks. But I'm not satisfied with my conclusion. I don't like it, because I think it's self-censoring our ability to create something very different. And I would like to know what method I could use to get a paper published which doesn't run the existing established benchmarks.
That's a major issue.
I'm sorry?
That's a major issue.
So
what
are your suggestions?
There's a lot of things you've opened up there. First of all, the problem with the conferences. So ISCA, which is our flagship conference, which I had forgotten, it was Wen-mei's talk, that the citation index, because nobody reads the papers. But the papers that get published tend to be of two kinds, which I think is a serious mistake, which you're relating to. One kind, if it's based on some technology that's like, 50 years from now, quantum computing, for example. If you want to write quantum computing, photons, the different cores are going to have lots of cores on the chip, so they're going to talk by mental telepathy to each other because we, don't have room for interconnect. If you do things like that, it'll get published in ISCA. Or if you do a piece of, so I don't know what the least that's an experiment we got to do. What is the least publishable unit that will still get published? See? So you do some little tiny tweak that nobody cares about, but you measure the hell out of it so that you've got lots of bar graphs and lots of, and that'll get in.
Yes.
In fact, I know some people that are developing tremendous publication records by doing just that. What you're asking is, why isn't your idea paper in?
Not only idea, I mean, we do have benchmarks, it's just not recognized by other people.
Oh, so it's a simple scalar issue.
It's not, it's not a simple scalar issue, because we're not using simple scalar.
No, the simple scalar issue is that, so, as André pointed out, for years, if you didn't use simple scale, your paper wouldn't get in.
Oh,
if you're
yeah,
not doing
that's it.
benchmark.
Yeah.
Yeah, so in fact, I have a friend, I'm not gonna mention his name, because I don't wanna embarrass him, but he wrote a paper, and I was one of the reviewers of the paper, and then I found out it was his paper. And he said in the paper that they used a modified version of simple scalar. And then when I found out it was his paper, I said, come on, you used simple scalar? He said, no. We modified it. We took simple scalar and we did RM star. So, and then we wrote it from scratch, see? So we started with simple scalar, so we had a modified version. And therefore the paper got in, because it was a modified
It was
version.
still the same benchmarks, probably.
That's right. So your benchmark thing is another thing. So that's why I call it an idea. So you want to say, I want to use my benchmarks rather than the standard set of benchmarks.
Well, let's put it this way. I would be willing to use standard benchmarks, but doing so would require overhead of multiple years.
So absolutely.
Let me ask you a question.
Yes.
How many grad students work on that project?
Can you repeat?
How many grad students work on that project?
What do you mean, grad students?
Graduate student.
Graduate students.
Yes.
Over time?
No.
Just
Currently?
He's about to make a joke,
No,
but
no,
you're
no.
not getting it.
no, it's not a joke.
I know it's not a
How
joke.
many graduate students are doing their thesis work based on this particular project?
Currently, two. Three.
Two. Increase it to 5 and have them do the benchmarks. That's his joke.
No. Here's the real problem. I have seen this over the years. In the early 1990s, a lot of the grad students are open to working together on a big project. What you just described is really a 10 graduate student project. If you really want to build the right tools, right compilers, right simulators, and fix enough of the operating system APIs to get the things running, and maybe even produce some enhancement of your benchmarks, it can easily be an 8 to 10 grad student project, minimum.
Okay.
So fundamentally, you are pushing a big rock uphill, which require 10 grad students pushing it, and they can probably make it. If you have 5 people who push it, they may be able to just hold that rock in the same place without rolling down. Now you have 2 grad students pushing it, and the rock just came down on you. Okay, so that's really what you experience.
You're describing the situation.
Yes.
So, however, you make an assumption,
Yes.
which is that the acceptance the acceptance of our submissions, at least to receive peer review.
Yes.
We don't really care about being published as much as we care about getting feedback. So that's really something that I want to highlight first.
Sure.
But you say the prerequisite to getting the attention of our peers to get peer review is that we do have to run these benchmarks. And I would like to challenge this assumption. Is that really the case? Because if that is not the case, maybe we don't need the 10 grad students.
You are absolutely right. And having run these program committees several times, I ran about 10 program committees in my career. I can tell you there is a chance that you could get a paper accepted without the standard benchmarks and so on. There is a chance. And the way to do it is just to keep resubmitting the paper until that chance hits you.
So I would say there's a very small chance. In fact, Professor Hu is absolutely right on a lot of the things he just said. And I should apologize for trying to make fun. When I heard you talking, I had no idea you had 2 graduate students. I assumed you had 6 or 7 graduate students.
Okay, now I want to say something else about this, because this is another part of my reaction. I would be glad to hire a couple of very bright undergrad students to work on this, because I have an exactly clear plan of what we should try next and do it. The problem I have now is that I don't have a track record that would justify my faculty to give me money to do so.
I can't help you solve it.
I know that, but you realize here there is a kind of a bootstrapping.
In our business, there's always bootstrapping. But I wanted to make a couple of points. One is the project you described really does require a larger group, as Professor Hu pointed out. And his number 10 is an excellent number. And in fact, you just added something which is terrific, undergraduates. And by the way, so I don't know about what goes on in your country, but in my country, You can get undergraduates to do these things without paying them because you do them as a special individual study kind of thing.
Yeah, we do that.
Yeah, and that can acquire the students. Now, the other part of his answer, which I didn't like actually, keep submitting it until finally you find a program committee.
I'm just saying it's a reality.
It's absolutely a reality. So the problem that needs to be fixed, what I see it is you have two choices. I don't see you coming up with a separate set of benchmarks getting favorably looked at, because he's absolutely right. Everybody on the program committee is going to say, why did they do that instead of the standard benchmarks? I'll tell you something even worse. Take the spec benchmarks and don't use all of them. Eliminate the 3 in which your idea doesn't work. And just produce the results for those benchmarks where it does work. Program committees are very sensitive to that kind of thing, and the paper gets rejected. So I think I think you have two choices. One is hire the undergraduates to do the standard benchmarks. The other, which we have to fix, is to sell and we've been very unsuccessful at this, sell the community, the program committee, on the notion that not every paper has to go through these benchmarks. Going through your benchmark doesn't help because, you know, as I say, I've got 10, I'll only use 7, you know. But sell it on the idea, sell it on the actual contribution of the thing, independent of the, you know, the boring turn the crank.
And how do you do that then?
Huh?
How do you do that? That becomes the next.
Well, so that's a problem we have. Right?
Yeah, that's a real problem. In program committees, you see generally all these nice guys that looks very fantastic, and suddenly you see the guys that you were thinking, that's a very intelligent guy, and suddenly he say, oh, by the way, they did not do that. Come on, that's the idea that's important. But you have to fight against that at the program committee sometimes. It's very, very difficult.
So maybe I'll offer a couple practical, additional practical approach. I mean, I really think that the first approach is the most practical approach in your situation. Right?
Keep sending the paper.
Yeah, so that's the first one. But the second one is actually being used by many more people these days. Many of these people view research as making a case. Okay, if you think about it, you have some ideas. So you're really making a case that this idea is worthwhile. You're really trying to make a case to people that this idea is going to make a difference, right? So this benchmark thing, this paper publishing thing is all about part of making that case. So some people are pushing the case too much towards the benchmarks and so on. So that's what we're discussing here, right? Here's a practical suggestion. Many people actually put their work into white papers on the internet, okay? And forget about the traditional conference publications. One example, the viewpoint from Berkeley about parallelism. And you know, I had a discussion with these, you know, we are competitors and we are, you know, collaborators in many ways. So, you know, we had these little discussions about these white papers and so on. And that white paper has probably higher citation index than most of the ISCA papers that we know about. Okay?
Does your promotion committee value white papers that are on the internet?
No. That's what I'm saying. I'm not saying the promotion committee will value the white paper. But what I'm saying is, if you want to make a real impact, maybe you'll not be promoted, but that's a separate issue. If you want to make a real impact and make a case for your research, that is not a bad venue.
Yeah, that's what we do anyway.
Exactly.
The problem is that we have this bootstrapping problem for getting the manpower to continue doing the work.
Yes.
And that will need to go through the promotion committees. So
and the funding evaluation.
So these agencies, these institutions need to be changed somehow, and we don't know how to do that either.
By the way, I like the idea that you started with. He's had his hand up. Go ahead. Yeah.
Yeah, if you are done with this part, I have a suggestion from outside architecture community. I made. So I'm a software guy, but I do check the ISCA papers. I don't quote them, but I read them often. And one thing I have seen, or we have seen, is that the computer architecture community went into the domain, into the area where they say, well, the programmer has written a program. Now I need to do all and everything I can to reverse engineer what his thinking was and make his original, re-guess what his original thinking was and turn his software into something that runs on the hardware. Now I'm putting it in maybe in a very sharp angle, but that's what a lot of research is going on. I have the C program, now let's try to guess what it really wanted to do and try to put it on the chip. At the same time, we get all these transistors, and we are way beyond just simple machines, simple hardware. So my question is, shouldn't the rethinking of the scope of computer architecture start from how can the programmer better communicate the intention that the software is about to do, and not let the programmer describe it in some way that he thinks is the best way to describe it, and then let the compiler and the hardware guess it. I think there is a break there, that there is a big divide that somehow would need to be crossed. That's what I'm seeing, really. And there are some research going into this, like these annotations. What's his name? August, I think, from Greece.
Dave August.
Yeah, Dave August.
Dave August,
Yes.
my grad student.
Yes.
Yeah, there are these ideas and incommutativity indications and those kind of things.
He's well-raised student.
Yeah, that's a first step, but that's like a small step on a very long road. So I think my point is, if you want to rethink computer architecture, start from that angle, giving better tools into the hands of the programmer to express what he wants to do, and not trying to afterwards guess what he really meant. Because that's what you do today in computer architecture. Try to guess what he really meant and execute it efficiently. And that's...
So should he know anything about the hardware?
Sorry?
Should this programmer know anything about the hardware?
Well, my point is that you should expose to him things that he can understand and use. And if you read in computer
So is that
architecture,
something that he should understand and use?
yeah, but what you expose today, or what the computer architecture exposes today, is way...
I'm sorry?
What is exposed today is way too low level, and most programmers don't use it consciously.
Should they? So so Professor Hu had that first slide yesterday with problems all the way down to electrons. And in the concept of the programmer writing a program, what you're advocating is, I think what you're advocating is the concept of pragmas.
No, not necessarily. I'm not
So think pragma in a broader context. A pragma means that the programmer is conveying what it is that he knows about this thing he's trying to do to the next level down.
Yeah, that's exactly.
Right?
Yes.
And that's what you're advocating, right?
Yes.
Yes. I would lump that into a thing called pragmas. Now, the question is, should the programmer also know what the hardware looks like if he's going to do, if he's going to convey this information in the best way?
I think what he has to know is what are the primitives, concepts, constructs that he should use. That's the main thing he has to know. And then maybe some more. Of course, you cannot be.
But that looks like a cookbook that the manufacturers are giving, and cookbooks is completely crazy. You are losing portability.
No, not cookbooks, but how should I put it? It's today a programmer is left alone to write the C code and do the synchronization stuff and do all that, and then comes the compiler and tries to guess, here he synchronizes, but what he really meant probably is this. And that's the part that will need to be fixed, this second guessing what he really meant. Take a look at the ISCA papers. 80% of them are trying to second guess what the programmer really wanted. And that's not the right way to do. I mean, it's not like there is a stupid guy up there who who doesn't know how to express what he wants, but he doesn't have the means to express what he wants. That's where the computer architecture should help him.
I agree. In fact, in 20 years, if we want to have some reasonable interface for the programmers to use in mainstream, we really should have started years back to be able to promote this kind of interface and really have a good popularity of these kind of interfaces in practice, right? I totally agree with that. That kind of research actually is related to what we're saying in the first discussion here. If you want to do any research like that, there would need to be people who are working on new extensions to the compiler, new extensions to the benchmarks, and new extension to the simulator whatsoever to be able to produce any results. Dave August, when he did that work, he actually demonstrated his work on spec. And he needed more than 10 grad students to be able to demonstrate these pragmas on the, on the spec benchmarks. And so what I'm coming back to is we are getting into a point where it's actually very expensive, and it's probably more expensive than most of us realize. That if we want to do something that has longer-term impact and longer-term benefit for the industry and for just for the field in general, rather than doing these incremental things, we really need to recognize the fact that we need to have critical mass in these kind of research projects and be willing to do a whole lot of work to make that case. Right?
But thinking back to what the previous question was, let's say someone, a research group with 20 graduate students, not 10 but 20, come up with that's a new set of abstractions that can be used to write programs, and they re-implement the spec benchmarks using those new concepts. They don't take the existing code, but they take their new concepts and re-implement it. Would they get accepted at this time?
The answer is today is no.
That's part of the point as well. It's,
the reason is all you described did not involve some kind of hardware mechanism or some kind of hardware apparatus. So for ISCA, the chance is going to be very low today. I'm not saying that this way it should be. Right?
It could be accepted at PLDI or AS+.
Exactly. AS+, I would say the chance will be very high.
So it is not desperate. You got simply the
as a practitioner, I'm not that interested in getting papers accepted, but I would like to see this kind of research actually happening much more than what August does.
We are agreed.
Few other people do. It has to go into that direction. That's what we see from the industry.
From industry, right?
It's broken. There is a big gap somewhere that needs to be crossed. Otherwise, it's using your analogy. You are trying to push a bigger and bigger rock up, and you push it 1 more centimeter and another centimeter. While what you would need to do is a big tractor to pull it and not just push it.
So, can you go back to this benchmark problem? Because it's somehow related. See, yeah, I'm sorry, I'm rolling back the discussion.
I'm sorry?
I'm rolling back the discussion.
Did somebody tell you could talk?
No, I assume I can, but if you object...
I'm listening, and I don't have to assume you can. I can hear you, so continue, please.
We all see that most of these things that are proposed also by ISCA are some special purpose techniques for a particular, special situation that a subset of application or application domains will benefit. And then on the other side, we keep bouncing back. Okay, you run the spec, or you run the mid-bench, or whatever the names are. And is it not, luckily we see some accelerator papers lately, reconfigurable, I'd like to see more, but not much chance there, right? The question is it not now the responsibility of the program chairs to educate the program committee that, there is nothing wrong with some special purpose, application-specific proposals to be accepted, and then, of course, to make the case, you cannot use the spec benchmark because it will not make sense for for all of the applications. Of course, you should run all of the benchmarks to show on which application domains or which applications you lose performance, to show how much you lose, or whatever power it is, the optimization criteria. But to really make the case for the subset that really makes sense for that particular technique. So, would this be a hard sell to the program committee members that they should, be more positive about this kind of papers? So, can this be another way to solve the original problem without, resubmitting infinitively, and maybe sometimes you get through?
You started with your resubmit.
Sorry, yeah.
I'm sorry.
No, so I think we're overstating the spec benchmark thing. How much, so what are you asking? A different set of benchmarks? Or are you asking, here's an accelerator that is good in a domain-specific environment and treat it on its own merits? So that's what I would advocate, is that there are some papers that do the measurements and there's some papers that deal with the idea. I think you're just asking about the idea, no? Or am I missing something?
No.
Maybe let me add a little
Please,
bit.
yeah.
I was listening to Gorgie, and there's something I learned about running these program committees. Most program committee members want to do the right things. Okay, so you know what? We always have a little bit of suspicion that these are kind of evil, shady people who are trying to push their agenda. But honestly, most program committee members really want to do the right things. But here's the problem. The problem is we make these conferences so competitive. So let's say we're going to have 300 submissions. And we're going to be able to take, let's say, 40 papers, which is high end. Okay, 40 papers is probably at the high end for most of the conferences. We need to kill 260 papers in order to get there. And whenever you need to kill something, it's always easier if you can find some potential fault with the paper. So if it's a small topic, if it's a kind of a special situation, and they measured, as Yale said, the heck out of it, and they have all these tables and so on, you look at it and say, no matter where I poke, I cannot really say that it's wrong. And that paper will survive much better than if there's another paper that is this new interface, okay? And you know what, it may or may not work, but there's some interesting properties, right? And someone, some poor grad students rewrote some benchmarks and then made it work. And the program committee, the immediate alarm is when those grad students rewrote the benchmarks, maybe they introduce some bugs that we don't know about, right? So that's immediately one weapon that you can kill the paper.
All and over, right? All and over, right?
Right? So what I'm saying is we need a lot more of those bigger papers. No question about that. As a community, as for the future of our industry whatsoever. But those papers are extremely hard to survive in a tough, competitive environment where people are looking for reasons to kill the papers.
So
right?
I think the insistence on proving your research on the benchmarks actually perpetuates the same idea of, the programmer did what he did, now we do all we can to second guess and reinterpret what he really meant.
Because it's a well-known starting point.
Exactly.
For people
but
to present
that is,
their work.
pushing forward.
I'm not saying it's the best point.
It's in the same cul-de-sac. You push in the same cul-de-sac forever.
So there's no question that Professor Hu is right, that those program committees, it's all about killing papers, because you got 300, you're going to accept 40, and as Professor Hu just taught me, by subtraction, you end up with killing 260 papers, and that is the sentiment of the program committees. There's one thing that he said that I didn't like, but it's a reality too often. Is that the program committee, because they're in attack mode, they'll say, well, there must have been a bug, and he must have introduced a bug in what he wrote. And that's again our fault when that happens. I think the way to correct it is, we're assuming the paper has a good idea. If the paper has a good idea, then it has to be dealt with as the good idea. And by the way, that implies something else, which is that the author of the paper can explain that idea in a way that the program committee can read it and understand it.
In half an hour.
Me and I don't want to tell you how many times I've had a struggle with a paper for a week, and then finally at the end of it I say, oh, is that all there is to it? Because it's written up so poorly. So if there's an idea, the program committee ought to deal with the idea and not say, well, it's a bug. See, if it's a good idea, the problem is the bug, you look at the thing and you say, you know, I don't believe this thing, so there must be a bug. But if it's a good idea, then it rings true. If it's written up in a way that, and you know, when you write, you should write for the people who read it, even though we pointed out nobody reads it. The program committee reads it.
Yeah, maybe that's the only one.
I think that's true. They may be the only ones. It has to be written in a way that they get it. And what I didn't like what he said was that, you know, it must have been a bug. But if it's an idea that rings true, you say, wow, I wish I thought of that, you know. I'm supposed to be smart. How come I didn't come up with it? You know, that. And that, I think, can trump this, you know, this spec nonsense. That,
so why don't, just an idea, why isn't there at these kinds, such conferences like a unbaked idea session? You know? Have a 10-minute session, 10-minute slot, explain your idea. You had a paper, it didn't get through to the main conference.
we've done it. We've done that many times.
So why isn't
nobody wants it for some reason. It goes for maybe a year, 2 years, 3 years, and then poof, nobody's interested anymore.
Because it's no publication, in fact.
Wild and crazy ideas session is what they call it.
Why isn't it included in the proceedings as a half-a-page paper?
So that could happen. Would that make a difference? I guess it would give a citation index, right?
Yeah.
Yeah, you are running late.
I'm running late. So as I said yesterday, you know, when we have to get on to the next thing, just, you know, say that's it. Do we do one more question because there's a hand up, or go ahead?
So, just going to make it's just,
Last question. So go ahead.
So it's a slightly different point, but I think it's one other thing that's unique about our science, if you can call it that, in that results are very rarely generated again by another group. And whenever we've tried to do this, we've generated completely different results, and what you find out is all the small details that are omitted from the paper make a bigger difference than the idea.
Yarmo, can we have another hour?
And it's just sometimes frustrating that people can submit papers. I know the chemists submit a whole load of data with their paper that goes online. And
so I've been advocating that if you submit a paper, you also have to submit, put on the web in a protected way for the evaluators to be able to we don't reproduce data in our field. We can have another hour or not?
You have that on Go ahead.
So, thank you very much.
Thank you.